5.4 RSG. Pretty much most of this is review by now. You guys had something similar to the ready in 5.2, so I'm not going to spend a whole lot of time on that. The only thing I want to point out is in the directions, use the given measures on the triangles to write the indicated trig value. You are going to write them as fractions first. Please make sure you do simplify your fractions. That's a very good habit. Then you're going to write your fractions as a decimal. So you're going to have two different answers here. So I'm going to go ahead and just do one of these for you, and then you guys will be able to practice the rest. So I'll go ahead and do the first one because the first one does allow for some simplification. So the sine of A, here's the angle I'm working with. So I'm going to label my three sides. The 26 is my hypotenuse. I know that because it's across from the right angle. The 24 is my adjacent, and I know that because it's directly next to angle A. And 10 is my opposite because it is across from angle A. So sine, if I remember SOHCAHTOA, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So opposite is 10. Hypotenuse is 26. Well, 10 and 26 can both be divided by 2, which gives me 5 over 13. So that's my fraction. Now I need to rewrite that fraction as a decimal. So I'm just going to use my calculator, and I'm going to put 5 divided by 13, which then gives me an answer of 0.3846. Now there's a lot more decimals that do go with that, but I'm going to just go out to the fourth decimal place, and don't forget to round when appropriate. So you're going to go through and do that for all four of these triangles. Then I want you to answer questions 5 and 6, please. And it's just pretty much asking you what is better, a fraction or a decimal, or more exact. So answer it honestly, please. Think about it. Which one is the most exact? Or in number 6, accurate? Answer. In this set, I only want you to do number 7. A silo, a silo is just if you're from the Midwest, if you've been to the Midwest, these are buildings, I guess you can call them buildings, and they hold grain, they hold wheat, they hold corn. They help store everything, and then they could load them into trucks for trains. So a silo is just a huge storage bin. And a silo it's this picture right here. A silo is created by a base of a cylinder and a top of a cone. So a silo looks like this. All right. So you have a cylinder, you have a cone. It is giving you enough information in order for you to find the total volume. So you have to find each individually. You're going to find the cylinder, and then you're going to find the cone, and you're going to have to add those volumes together. As a bonus question, go ahead and try 8 once you have the volume if you would like to. How much can they actually store in there bushel-wise? So bushel is just an amount of whatever grain they are filling the bushel with. So if you know how big a bushel is in cubic feet, and don't forget volume is also going to be in cubic feet or feet cubed, you will then be able to just do one little simple math operation to find how many bushels will fit in that silo. You're also welcome to do 9 and 10 if you want to. You're welcome to try them, and if you need some help, come in and see me, but it's really not a necessity for you guys to do 9 and 10. And then the go. Don't want to do too much of the go for you. It's a really good review in preparation for your Practice Smarter Balance test that's coming up in a couple of weeks. and then your actual Smarter Balance test that we will be taking in April. If you need to look back at the notes that we did in Module 3 on polynomials, or look back at the work that you might have from Math 1 and Math 2. When it's asking you to identify what you know about the function, think about the type, think about intercepts, think about what it's supposed to look like, think about the degree, any of those properties of polynomials that might help you create a graph. And then don't forget the end behavior are the arrows. It's whatever direction those arrows are going. And when you're looking at x is going to negative infinity, that's your left arrow. And when x is going to positive infinity, that's your right arrow. And then feel free to check your graphs in Desmos. Just type those in and see if you graph them correctly. So you're going to go ahead and do that for 11, 12, 13, and 14. And if you need to, go ahead and get rid of these parentheses if it helps you. Or 11, it's actually probably easier to leave them. In 12, it might actually be easier for you to think of factoring. Please don't forget that factoring is always a part of something that is quadratic. And even though it doesn't ask you to factor, it might be helpful. 13, pay attention to maybe what that negative might be doing to your graph and what the exponent means. In 14, just a quick hint, it might be beneficial if you distribute that 2 first. So different things to think about. And again, you can check your answers on Desmos to help you with that. All right, that wraps up the 5.4. I know you're probably wanting a little bit more on the go, but that's a lot of review. So look back at the old stuff, and if you need a little bit more support on that, then you know where to find me, morning lunch, or have some homework questions ready for tomorrow, since tomorrow is a homework question day. See you then.